Hello guys, and welcome back to the AIME problem solution video. Today we've got a problem here, and as always, let's first start off by reading the question. So, find the number of 4 element subsets of 1, 2, 3, 4, all the way to 20, with the property that 2 distinct elements of a subset have a sum of 16, and 2 distinct elements of a subset have a sum of 24. For example, 3, 5, 13, 19, and 6, 10, 20, and 18 are 2 such subsets. Now let's first look at this part. So we need 4 elements in one subset. So our 4 elements, let's say, for example, to be generic, are going to be A, B, C, and D. Okay? Now we have 2 cases for this to be satisfied by a condition. Now, let's first start off with case 1. For case 1, we have A plus B is going to equal to 16, and C plus D is going to be equal to 24. Now in this case, we can see that for A plus B to equal to 16, we have a couple of ways to do this. We can have A is going to equal to 5. We have already down here, sort of in like a subset manner. We have 115 for A and B, so I'll kind of write it down here. So this is going to be in the format of A and B here. We have 1 and 15, we have 2 and 14, and this continues on to 7 and 9. And here in total, we should have 8 different ways to do this. So I'll write it down here, 8 different ways. Now for the second one, we consider C and D. We should have C and D here as a format, I guess. And since D has, at most D is going to be 20, this means that the smallest possible number for C is going to be 4. So 4 and 20, all the way to 11 and 13. And here, there are going to be 7 subsets. So we see that for case 1, there should be 7 times 8 subsets, right? Well, not exactly, because we've actually ended up overcounting. And there are actually 3 cases where we've overcounted. So I'll show them right now. So for our first case, B is going to be equal to C. Now sadly, there isn't actually a really good way to solve this other than trying to bash all the things out. So if B is going to equal to C, I'll just write it out for you. We have B equal to C equals to 11, 10, and 9, and this won't work as we need them to be all distinct. The second case is that A is going to be equal to C, and this is going to be equal to 5, 6, and 7. And the third case is going to be that B is going to equal to D. And this subset has four things, which is that B equals D equals to 15, 14, 13, and 12. And as I said before, there isn't actually really a way to solve this out. You just kind of need to brute force and bash through. Now from here we have 3 here, 3 here, and 4 here, which means that in total we have 10 cases where we've overcounted. So our final answer for this case should be 56 minus 10, or 46. Now let's look at our second case, which is case 2. Now in case 2, we have A plus B equals to 16 like before, and A plus C is going to equal to 24. So in other words, in here we have one element that is repeated twice in both elements. Now in order to solve this, we can start off with what the smallest value of A can be, which is 4. Similar to here, as you can see here, we need C to be 20 and A is equal to 4. So we have our first subset, which is 4, and obviously B is going to have to be 12, C is going to be equal to 20, and let's say D is going to write, for now, question mark. And here, as you can see here, A can be, for the smallest value A is possible, is going to be 4, and the biggest possible value is 15. So A is going to be equal to a number from 4 to 15. However, there are 2 conditions. A cannot be equal to 8 and 12. And this is because if A is equal to 8 and 12, then B will be, respectively, B and C will have to be equal to 8 and 12, and we can't have 2 repetitive elements in our subset. So from here, we see that there should be 10, so this means that there's going to be 10 possible things, or 10 possible values for A. And for the question mark, we have 3 elements, and then the question mark, our subset in total that we can pick numbers out of has 20, so this means that we have, for question mark, there should be 17 possible answers. So this should be 10 times 17, or 170. However, similarly to before, we've actually overcounted again. Now here, it's going to be the same way to this. So our first case of overcounting, which is that C is going to equal to D, which is going to equal to 13, 14, and 15. And our second case is that b is going to equal to c. It's going to equal to 9, 10, and 11. And here in total, we have 6 cases that we've overcounted. Now, as I said before, there isn't actually a really good way to sort of, I guess, like solve how many ways you've overcounted other than just brute forcing and bashing through. So sadly, we have to count everything out. So this means we've overcounted 6. So our final answer should be 170 minus 6, or 164 for case 2. Now this means we need to add up these two, so from our value from case 1 and our value from case 2. So this should be equal to 164 plus 46, which should equal to 210. So the answer to this problem should be 210. Thank you guys for listening. If you have any other solved problem, please let me down in the comments, and thank you guys for listening. Bye!